So this is going to be the beginning of chapter 7.4. And in my opinion, 7.4 and 5 are the two most important parts of finance. Um, you know, obviously it's going to be the last two lessons of the entire year. But when it comes to making math applicable in terms of finance, it is the two main formulas that you're going to be using, I think, for a big chunk of the rest of your life, I think. So let's work through it. Okay, up until now, you've done chapters 7.2 and 3 for compound interest, and I'm hoping you have some practice with it. I hope you do have some practice with it. Excuse me. We're going to start off with a question very similar to what we've done in 7.3, and then I'm going to sort of poke holes in it to show that it's incomplete and that it doesn't necessarily help everyone in life, which will segue into our new lesson. Okay, so here we go. I'm gonna read what I have up here, and we're gonna do the calculation together. If you did do the minds on, good for you. If you haven't, please follow very carefully. Until now, all the finance questions you've done so far involve one lump sum left in an investment and then watching it grow. If you remember, it's A equals P 1 plus R over N NT, right? So this was your lump sum. Maybe I'll just highlight that so that we are reminded, right? You put the p-value somewhere, and then you are going to increase it by a certain interest rate, right? So one example, after Mr. Kim's class, let's pretend, you decide to invest a lump sum, which you don't know, right, into the S&P 500, which gives an average return of 8% per annum. But being the stock market, you can let's just pretend that it's compounded daily. Okay. And if you're with me, just have your calculator handy. If your goal is to have $1 million saved up by retirement, how much must be invested today? So that's p-value. Assume 48 years, because you are technically, I believe, you should be 17, unless you had an early birthday. At which point, happy birthday, I guess. And what do you call it? Yeah, so you have 17, you're going to retire at the age of 65, which means you have 48 years for this to grow. Let's plug it in. 1 million equals the principal that I do not know yet. 1 plus 0.08 divided by 365. This is 48 years times 365. That's a big number. Okay, let's figure out what that is. Oh, and I misplaced my calculator, so I'm gonna go get one. Everyone else, would you please really just participate with me and try to finish that off? Okay, 8% divided by 365 plus 1, all to the power of 48 times 365. Wow. So I would have gotten, and a couple of people, if you can confirm with me, so I don't make any mistakes as we go. Right. Which means take the $1 million, I'm going to divide by this much, and I get some, yep, Simon, thank you very much. That's all I need, at least just one person confirming with me so I don't make a mistake and confuse everyone. So that would bring us to 21,502 and 65 rounded cents. So honestly, yeah, you have 48 years. Amazing. I do not. So you have time that I don't, and you will be able to become a millionaire much sooner than I would, or easierly, more easier than I would ever be able to. But let's be honest, how many people at the age of 17 have $21,000 in their bank account? You might, right? I'm not saying it's impossible. Some people definitely might, but when I was your age, I did not. The only money I had, and especially remember, I told you the story. I wasn't a spender, but the amount of money that I actually had in my account only amounted to the gifts that I received from my uncles and aunts when they visited me from Korea. So it amounted to like a couple thousand, right? And I thought I was, I felt nice about it, but nowhere near 21,000. So I'm assuming that's going to be like most people. Do you have this lump sum? Most will say no. Does that mean everyone without this much is without hope? That's not true either. Realistically, both children, adults alike, we will have some way of making money, whether it's a job or a career or um, a business or retail, whatever. Okay, you will work your ends and make some money, and then a certain amount of the money you make will be invested every month, right? It could be every 2 weeks, it could be every month, it could be every half a year. Everyone's a little bit different, but that's how we typically do. We have a little bit putting it into the investment, and then next month a little bit, 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 so on and so forth, all the way until 48 years have passed. But that's the magic of it. Everyone, consider this idea. If I put in, let's say, $100 right now, this will grow in interest for 48 months. The second one, so in next month, I put in $100. This will be able to gain interest for 47 years and 11 months. The third bag of money that I put in will be able to grow for 47 years and 10 months. And the next will be 47 years and 9 months, 47 years and 8 months, so on and so forth until I think you get the point, right? You don't earn as much interest, right, as the first one that you put in, all the way down to the very last $100 that you put in, where it doesn't even have the opportunity to earn any interest. It just sort of stays there. But does that look familiar to you? If you put in a lump sum and it grows in interest, that would be what we call a geometric sequence. Each of these is a single term in a geometric sequence because they're multiplying. And then if I asked you, hey, what is all of this in total? Rather, what is all of this in total? That's the first payment plus the second payment plus the third payment plus the fourth payment plus all the way to the last one. That's a geometric series. And that's where we are going today. I'm going to show you that you don't need to have a lump sum. We are going to use our knowledge of geometric series to see how each individual payment will also snowball just as well. So, hope for the rest of us that aren't rich, right? Please take a look at our sheet. That is chapter 7.4. I am going to open it here. If you have it in front of you, please take it out and look at the first page. I'm going to paint a picture just like we did for, oh, I need to go to our website. I'm going to paint a picture just like we did for any other, I guess, chapter 7 section. For now, if only I could get that faster. I thought I had it with me. Okay, there it is. Let's share. All right, sorry about that delay. Annuities. Annuity is basically a finance term. It's a special term that means putting a small deposit or making a small payment periodically, again and again and again, the exact same amount again and again and again and again for an extended period of time. In case you are taking economics, I don't want you to be confused with the economics course, and so this is what we are going to call an ordinary annuity. If you're not taking economics, don't worry too much about the word ordinary annuity. Just know that we're making the payments at the end of each period. Okay? That still might not mean anything to you. So let's give an example to have a better idea of where I'm going. This is ordinary or simple annuity. Here's my scenario. Mr. Kim wants a Europe trip in exactly 4 years. What does that mean? That means if I'm doing it monthly, I have 48 months. He saves up $100 each month into an account that earns 3.6%. So R is 0.036 per annum, but compounded monthly. So I'm saving up every month, and that is when they calculate the interest at the same time. So let's represent this on a timeline or a time diagram. This would be right now, it's like 0 months. This would be 1 month, this would be 2 months, 3, 4, 5, 6, 7, 8, 9, 10. This is the 48th month, which means this must be 47, which means this must be 46. On top of that, remember on the first month, I don't earn any money yet, so I don't have $100 to save. But after 1 month, at the end of the 0 month, in other words, at the start of the first month, I have $100 to put in. I have another $100 to put in. $100, $100, $100, dot, 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 dot. On the 46th month, I have $100. I have $100. I have $100. And so if I were to just add it up as is, what's $100 multiplied by 48 months? It would be just $4,800, right? But remember, this is growing in interest by 3.6% every year. So the $100 that I put in at the very end, I don't have any time to earn interest. But the $47 that I put in, it had 1 month of interest to earn. So that was basically going to be 100 multiplied by 1 plus 0.036 divided by 12, right? And how many months? Just one. That's going to be one. But I don't have much space on this sheet, so I'm actually going to simplify this. Okay, I'm going to do, I'll take a look up here. 0.036 is going to be divided by 12. So that's going to be 0.003 every single time. Okay? So this is 1.003 multiplied once. Uh-oh. Oh no. Why is it not writing anything? Yeah, Noah, I am writing something on the screen. Everyone else not see it either?
No, I
No,
don't
we
see.
can.
Oh my gosh. Oh my goodness. What? Oh no, the board is not broken. I was writing stuff, but I guess it didn't I might actually have to bust out Adobe Premiere and do some cut and paste on this. Okay. All right, people. Let's start from the top. This is what I was writing. Do you see this writing now?
Yeah, we
Yep.
do.
Okay. Sorry about that, everyone. Okay. I was writing all this stuff. Ugh. Anyways, it should be recorded, I think. If not, then my life is terrible. Anyways, okay, let's do this again. 0 months. This is 1 month. That's 2 months. 3, 4, 5, 6. If that last payment is 48 months, that means this must be 47. That means this must be 46. Today's really just not my day. Okay, next, let's keep moving on. The first month, as I said, we didn't have any money to save because we didn't make money yet. But as we continue to earn money, the first time we can deposit $100 is the end of the 0th month or the start of the first month. And then $100 here. $100, $100, $100, $100. And then the 46th month, I have another $100. 47th month, I have another $100. 48th month, I have another $100. What does that mean? Well, as I was saying before, if I put in $100 48 times, I have $4,800 in total, right? But as we were saying, okay, so yeah, in this 4 years, that's supposed to be 48 months. That's where I got the 48 months. And this is how much I'm saving every single time. So this is my repeating payment. An earning of 3.6 is supposed to be 0.03 cents. However, I am calculating the interest monthly. So every single month, I am going to be earning, just divide that into the calculator, 0.003. Okay? So this is how much I'm earning every month. Does everyone see the writing so far? This one's okay? Okay. Oh, jeez. Sorry about that. All right. Now, as I was saying, the first month, sorry, the very last month, the amount that I put in on the 48th month, it didn't have time to earn any interest. However, the 47th month, the payment that I made, it actually had 1 month to earn interest, which means this $100 is going to be multiplied by 1.003, of course, to the power of 1. Under that same context, think about how much interest the 46th payment was, right? It had 2 months to grow in interest. So it would be multiplied by 1.003 and then multiplied by 1.003 again, which means I am multiplying it by that squared. And then there's another one, the 45th month, the 44th month, the 43rd month. The list goes on until I get this one, which is the $100. And how many months did it get to grow in interest? 48 to 46 months. And then the very first ever payment, because it was made on the first month, it only had another 47 months to earn interest. And my question to you is, what's the total? How much money do I have actually at the very end? And at this point in time, I'm hoping that things look a little familiar to you. Take a look. 100. Sorry. When I say total, it means take this 100 plus the 100 times 1.003 plus 100 times 1.003 to the power of 2 plus to the power of 3 plus to the power of 4 plus to the power of 5 all the way to 46 plus 47. And if you look closely, you will see 100 at every single term. You will also see the same ratio being multiplied at every single term. And what's interesting, as a final bit, is that the exponent is growing from 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 46 and 47. And 47 is basically 48 minus 1. That is the number of terms minus 1. An annuity can be written as a geometric series. So the sum is going to equal a bracket Rn minus 1 over R minus 1. But remember, in this particular case, the R is not the rate of interest. The R is just a ratio. When we change into finances, the R is going to be 1 plus the R over N that we've been using for finance questions all the way up till now. So every time I see the R, I'm going to replace it with 1 plus rate of interest divided by compounding N. Same with here. Every time I see an R, I'm going to replace it. And so that will bring us to the final formula that's on the bottom of the sheet. Let me do this. Let me take this. I'm going to put it here. I am going to erase these lines, and I'm going to calculate this for you. Let's see. What is the repeating amount for this geometric series? It is 100. Or rather, what is the starting value? It is 100. What is my ratio for the geometric series? It is going to be 1 plus 0.036 divided by 12, which happens to be 0.003. What is my n in this case? Well, that would be the number of years times compounding period. In other words, it's going to be 4 years, but I do it 12 times. The n value is going to be 48. So let's plug this in. The total, or future value, or final amount, whatever you want to call it, is equal to 100 R n minus 1 divided by I'm going to do this. I'm going to write it as 1.0.003 minus 1. Let me raise this so a bit. Okay. And you might notice also that the ratio has 1 plus 0.003, and I have to subtract by 1 anyways. So you can actually remove that altogether and just leave it as the 0.036 divided by 12, right? You can just leave it at that. For now, let's get used to the formula. You can do the 1.003 minus 1 like that, just as we were using the geometric series. What is my total? Everyone should have a calculator and working through this. I'm going to give you about 30 seconds. See if you can calculate it during this time. There it is. I see something in chat. Yeah, right on, Saima. Okay, so this is, I mean, is it as good as what is it, compound interest where you just put a big lump sum and let it sit there and grow? It doesn't grow as fast, obviously, but it allows us to still take advantage of geometric sequences or compound interest, even with small pieces. But we're just making small payments of compound interest and letting it grow individually, right? Again, this is not the same as putting a huge sum and watching it grow, right? We're doing a little bit at a time, but it gives poor people like me hope, okay? And this is geometric series. This is annuities. Geometric series in the form of finances. And if you compare, if I left it in the bank, it would have been $4,800. But by putting in a little bit at a time and investing a little bit at a time, I still took advantage of compound interest, letting that tiny bit on the $100 snowball, and I earned 350 bucks. Okay, that brings us to that formula. Okay, so if you remember in the denominator, it's supposed to be 1 plus r over n. Sorry, let me. If you notice in the formula, the ratio is supposed to be at the top and the bottom. The ratio is here, and I should also have a 1 plus here to be exactly the same as the top. However, remember that the formula also asks you to subtract by 1 after and then subtract by 1 after. Subtract by 1 is here, subtract by 1 is here. In the numerator, there's an exponent, so you can't just subtract by 1 right away. However, in the denominator, the 1 and the 1 cancel each other out. That's why you are left with just r over n in the denominator. That's all it really is. That's all it really is. But it's just a matter of being able to use this formula. So I have a couple of questions you can do from this page on this sheet, but let's try to make it a little bit more relevant to you. We're going to do number 3 afterwards, okay? But for now, let's do something that might be more interesting to you. A long, long time ago, I asked you, how much money are you comfortable with saving every single month? To the point where, how much money are you not going to miss? And be honest with yourself, right? Some people would be like 10 bucks a month. I'm not going to miss 10 bucks a month because any money I do make, I want to go out with friends. I want to have, you know, I enjoy the finer things in life. I want to go out and, get that steak dinner. Okay, I want to go out and I shower my friends with appetizers when we go out. Like I'm a growing boy and I want to eat 3 meals, like because I can actually finish 3 meals. I don't know how much high school kids eat nowadays, but I mean, when I was a kid, I ate for three. Right, it was to the point where my parents literally told me that they didn't save a single dollar when I was a teenager because I was eating it all up. Yeah. Anyways, so ask yourself this, and I like someone to I guess offer their numbers, but if your number doesn't match with theirs, whether you're super rich or super poor, it doesn't matter. Ask yourself how much you are comfortable saving, and ask yourself how much you're not going to miss every month. If I was in high school, I did tutoring while I was in high school, make side money, and I think let's see, like 40, 40, 40, 40, maybe about 200 bucks a month I made. But I wasn't a spender. So I would have been comfortable at least saving 100 bucks a month. I don't know about you. Okay, let's take an average. I just got a message from Murdoch saying something. Let me address it in just a second. Okay, we got 10 bucks, they got 100, someone else, another number. Let's just do an average. 20, okay, 10, 20, 30. Do I see a 40? Someone give me a 40. Okay, so 10, 20, and 30, and 40. You know what? Then my number is not, doesn't count. So 10 to 40, 50 average divided by 4, 25 bucks. Okay. My recurring payment, notice how I'm not using the letter A anymore. My recurring payment is $25. So I'm not going to miss $25 every month. No matter how little or how much I save or how much I make, I'm not going to miss $25. Okay, let's pretend we are going to invest in the stock market. Okay, you're going to be 18 or your parents opened an account for you, whatever. And over the past, let's say 30 years, its average return was about 8%. Okay, and this is true. There was a recession in 2008. There was a recession in like 1990, 1995. There was a recession, um, a big problem in early 2010s, and then COVID in 2019, right? But all that together, it still is giving a decent return of about 8%. And because this is a stock market, no, wait. Because we're doing it monthly, the end value is going to be monthly, and you're going to start when you're 17 years old all the way to you're 65. Remember, this means that you are never going to miss a single payment of $25 every month, okay? That's the compromise. You told me that you're not going to miss it, so you have to commit to be able to saving $25 every month. Okay? What is the future value of this annuity? Remember that the total sum is A times R n minus 1, R minus 1. So in terms of finance, the future value is going to be my recurring payment, oops, and then 1 plus the rate over the compounding, and then the number of years, multiply the compounding, minus 1, all over R over N. My recurring payment is $25. The interest rate is 0.08, but I'm going to divide it into 12. I'm doing this for 48 years and 12 times a year, subtracted by 1, and then this is 0.08 divided by 12. I think you might be surprised. Do this for me. For those of you who are still struggling with the calculator, okay, um, please calculate from darkest color to lightest color, okay? So do this bracket first. 0.08 divided by 12, and then that answer plus 1. Next, apply the um, exponent. So 48 times 12, 48 plus 96, 48, 576, I believe. Right. And then you're going to, again, you're going to subtract the answer by 1. And then you are going to multiply by 25. And then you are going to divide by this entire fraction. What do you get? I got a slightly bigger number. Maybe there was, oh, slightly smaller. 0.08 divided by 12 plus 1, all to the power of 576 minus 1 times 25 divided by 0.08 divided by 12. Yeah. Final answer is 168,511,29. So 25 bucks a month, right? You saved up a decent amount. At that point in time, you might be wondering, or you might maybe be a little bit more selfish for yourself, more a little bit more greedy for yourself, right? If you can do $25 a month and it turns into a six figure, lump sum, how much do you think you might be able to stretch that to, right? It's a thought. It is a thought, right? From here, let's say you get a little bit older and you're like, you know what? I'm not doing anything valuable with this money. I'm just letting it sit in the bank account. Maybe I can invest 100, right? Turn that into 100 and see what that turns into. Well, I'm basically multiplying it by 4. If you multiply that by 4, essentially you would come up with, right? Almost $700,000. A little bit more than that, you'd be a millionaire. So that's the thing, okay? That's the catch. You have 48 years. If I want to have the same amount as you, if I want to start saving up because, you know, I'm like, ooh, look at how much they're saving. I can do that too. I would have to save up so much more. So now let's go back to that $1 million question. I think in my whiteboard we had it, right? Going back to that $1 million, how much do I have to save every month if I want to be a millionaire? Again, we don't have $21,000, right? I don't have it. I'm not sure if you do. But I am working and I am able to put in a little bit every month. So let's do that. I'm going to clear this. If my final future value goal is going to be $1 million, my rate from the stock market is going to be 0.08. I am going to be doing this every month. The amount of time that I have is 48 years. What is my recurring payment? So let's do it. Once again, the formula is future value is equal to my recurring payment multiplied by 1 plus the rate of interest divided by the compounding, all to the power of n times t, subtract by 1, and divided by r over n. So now I'm going to plug in the numbers. I don't know what my recurring payment is. This is 1 plus 0.08 divided by 12. This is 12 times 48 minus 1, 0.08 divided by 12. So do that bracket portion with me and see if you get the same answer. I get that. How about you? Perfect. Okay, so I have at least one confirmation. Great. So I'm going to take $1 million, divide by 6740.45. My R is $148.36. It might be asking for a lot for a high school student, but can you save $150 a month starting from now? And honestly, if you're really hungry for this, you can. I remember in high school during the summer working like a paint job or boxing shelves at Shoppers Drug Mart, being like a box boy at grocery stores. You get paid minimum wage, but minimum wage nowadays is like 14 bucks or 15 bucks. You work a full summer. I had friends that were able to save up like a good $3,000 during the month and a half that they worked, right? And yes, they spent most of it, of course. They gotta get that new shoe, they gotta cop that new hat, whatever, whatever. But if you're able to take that sum, think about it. I'm just gonna do in the calculator. 3,000 divided by 12, that's 250 a month. Out of that 250 a month, If you can put in $150 of that and invest it, and you keep that up for the rest of your life, and if you can do it at the age of 17, you can do it at the age of 20, you could do it at the age of 30, you could do it at the age of 40, so on and so forth. If you can start now, while everyone else is working some 9 to 5 job, you are already on your track to becoming a millionaire. And I'd like you to appreciate the fact that you have something I do not have, and that is 48 years of investing. How do I know? Well, take a look. What if you're dealing with me? What if I'm like, oh, my students are going to make so much money. I want to be like that. I want to be like that. How much do I, how much does Mr. Kim need to put in every month if I want to have $1 million by the time I retire? What is the difference between you and me? I don't have 48 years. Let's pretend, because I'm pushing 40 soon. Well, not soon, but pushing 40. Let's pretend, let's say I'm 35 and I push to 65. So I only have 30 more years to invest. And I start investing right now. I have 30 years left before I'm 65. I'm going to push hard. I want to be a millionaire too. What does that bracket turn into? Times 30. I have this. Someone want to please confirm? Just let me know if I'm doing anything wrong. Did I get the same answer? No? Okay, then I'm gonna have to confirm it myself. The power of 12 times 30 minus 1. Well, I could have made a mistake too. So plus 1, all of that to the power of 360 minus a 1 divided by 0.08 divided by 12. Okay, I think I got it. I think it's right. So if I divide $1 million by this amount, compare this with 150. Because so and then this is because of 30 years of investing versus 48. I missed 18 years of investing, right? What does that mean? This is 650. That's like times 4. This is more than 4 times how much you're doing it. Because I missed out on 18 years, that's 18 years of snowballing, which means if I want to catch up to 18 years of snowballing, I have to pay up more than 4 times how much you're paying just to catch up to you, which at this point in time is impossible because there's too many bills to pay, right? Truth be told, if I were to put together my pension, I think it's like this is going straight out of my paycheck, and then from that, I am putting $50 a week for both my girls, so $100 a week. Let's say 4 times a week, so 100, $400, and then I gotta take care of my baby mama, so $25 times 4, that's another $100 a week, $100 a month. And whenever I can, I put money into the stock market. So far, let's pretend I have like $100 a month, right? I am pushing hard, trying to put in approximately $1,000 a month into investing right now. Out of that, This right here is going to be gone very soon because it's for my baby's schooling, for university or college or wherever they want to go, right? And so if you take a look at that, I'm actually only putting in about 600. There's no way I can catch up to you. There's way too many bills to pay. And that's reality. So don't take your time for granted. There's a reason why your parents or your guardians or whoever is above you is really pushing you to make best use of your time because time is something you'll never get back. Okay? I don't mean to sound philosophical here, but it is the reality. Um, so we've done a lot of examples. As promised, I still do want to do one of those questions on the back of the sheet, and then we'll call it a day. All right? This is annuities. Just because you don't have a lump sum doesn't mean you can't save. You can calculate just a little bit every single time, and it will snowball. Let's take a look. Number 3. Okay. Mr. Kim begins saving up for retirement from the age of 30. According to a CIBC survey, the average Canadian believes you will need $750,000 to retire modestly. Keyword. If Michigan begins investing $650 a month and expects a return on interest at, here's a higher percentage, 10% compounded monthly. Will he reach this goal by the time he retires? Okay, let's highlight a couple of pieces. Okay, I'm starting at 30 and I'm going to 65. $650 a month. In other words, it's repeating. Everyone always look for keywords that tell you that it's going to it's going to repeat. Okay. Return is 10% compounded monthly. Let's write it out. What is my final amount? My recurring, notice I'm not using the p-value, I'm not using principal. There's no such thing as principal here. My recurring payment is 650. My rate is 0.10. The amount of time that I have is 35 years, and I'm doing this every month. Let's put this together. Oh, this is also future value. My future value is 650, opener bracket, 1 plus 0.10 divided by 12, 35 times 12, minus 1, 0.10 divided by 12. I'm going to write the answer down, but keep going if you've already started. Just make sure you aren't making any mistakes with the calculator. Now is a good time to confirm that you are doing the operations in the correct order. This is how much I would end up with at 35 years, assuming I get 10%, 650 a month. That's pretty sweet. I won't wait. You guys can confirm for yourselves whether you're doing it correctly or not. Are there any questions about annuities? Maybe the formula, or maybe you want to see another example. I'm all for it, but I'm hoping above all else, I'm hoping that you are able to see um, just how easy and difficult it can be to financially plan for your future. It's easier for you now because you have 48 as your exponent right here. But every year that you wait, that exponent becomes smaller and smaller. Okay. Any questions? No? Hmm. Okay. Please note, questions 1 to 6 is an annuity. Question 7 is actually not an annuity. I'm not sure why I added it there, but just be aware. There are many more questions you can do from the textbook for sure. I'm just going to make a quick blurb. If we were in class, I would have asked you to start working on your optional assignment. We do have 15 minutes, so I think I'm going to open it up and just quickly run down what it is I expect of you. Actually, when do I next see you? Well, I see you guys tomorrow and Thursday. You know what? I'll save that for later. Do we have to do 7? Well, I guess not. You don't have to. You know what? I will save the rundown of the optional assignment until tomorrow. We aren't in person to miss. Are you serious? Like fully schools are closed? Whoa, 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 whoa. Hold on.
There's a bunch of news. If you look at the Toronto Star, they just Doug Ford just announced that schools will be closing tomorrow up until after.
Oh no. Okay, okay, miss sec. Okay, I just got the email from TDSB too. Toronto Public Health, all schools, including TDSB, closed as of Wednesday and remain closed until the end of the long week, the March break. Ooh, Lord of mercy. Okay, okay, people. I don't see you. So I don't even know if I'm supposed to go in school then. Okay, okay, that's for me to do. You don't need to deal with that. Whether I teach from the classroom or whether I am teaching inside from home, this format is going to be exactly the same. We're going to go through Zoom. I'm going to open this up and we'll talk, and I'll have a camera so you can see my face and my hand gestures and whatnot. I will still go through the assignment with you, and it might be a little bit boring because we have to be virtual for 3 hours. And so when I ask you to take a break, you'll be taking some long breaks, especially to rest your eyes, because staring at a monitor for 3 hours is death. Okay, don't do that. Um, yeah, I will make more things known as I discover them. Okay? I'm so frazzled right now. Yeah, so Kiara, it just says that because of the scare and the rise in COVID cases, no in person. So don't come to school, join online, okay? Join just like you did right now in the morning at 8:45 or whatever. Could you maybe post for those that didn't grab one for, you know what, Nathan? It's actually going to be go live tomorrow because um, you still need 7.5 to do the assignment properly. So if you want, just consider today to be a day where you can actually work on the Chapter 7 quest, maybe, or do as much of it as you can and keep it handy. I think the quest has one question where you have to know Chapter 7.5. Okay? But last thing I'm going to leave with you, the only difference between geometric sequence and geometric series, in other words, regular compound interest and annuity, is carefully looking for the question to say some kind of repeating payment. So if you take a look at this question here, like let's say number 4, um, what deposit is made at the beginning of each month? So clearly there's a repeating amount. Deposit $1,000 at the beginning of each month. Again, a repeat. How much money should they be depositing quarterly? In other words, a repeating contribution. Okay? If you see something being repeated, it's going to use the letter R, right? Not the letter P. It is not principal. It is recurring. Okay? That's it. That's all. Whew. Last questions. Going once, going twice. All right, everyone, it's 3:05. I'm going to dismiss a little bit early. I'm going to use this time to try to edit the video and upload. Your homework, your homework is number one, you have your quest for chapter 7, okay? You need 7.5, so maybe do all the questions you can until you hit a question like that. Number two, assignment, which is optional if you took one already. And Noah, if you are, was it Noah? No, Nathan. If you are curious and you sort of want that copy anyways, I'll just make it live as soon as we leave. Okay? Number three, chapter 6 should be done. Oh, 7.4 textbook slash practice questions. Okay, and that's it. And for number four, remember Zoom tomorrow morning. That is crazy. The April break schedule for next week will continue as normal. Please note that unlike the closure, this applies to all TDSP schools. School-age children, however, pre-age will continue permitted. We recognize there still may be a number of questions. Okay, yeah, so it looks like it's going to be remote learning. So join me online. Oh, that's a really good question. Um, um, yeah, both cohorts do not need to join. So only join if you are supposed to come to class. Okay? It doesn't make sense that I ask everyone to join 3 hours twice. I think that's overkill, and we're basically at the end of the class anyway, so let's just pretend it's yes, it will be the same link. And someone mentioned I might have accidentally made due today. Oh, no, it's not due today. Sorry. Just as I said in the beginning of class, I thought it had to be due this Friday, but I'm supposed to technically have class with you on the Tuesday after the March break. So it's going to be due basically at the very end of class. But if you can finish it sooner, finish it sooner. Whew. Any other questions? Okay, from the silence, I guess it looks good. If you want to stick around for more questions or you have a personal one, please do so. Otherwise, everyone, you are dismissed. Thank you so much for hanging out, and yeah, stay healthy, please.